Hey everyone. So let's talk about something every single one of us who writes code has experienced. You start a project, it's clean, it's beautiful, and then over time it just turns into this tangled mess. Well, today we're diving into a set of tools that can stop that from happening. They're called design patterns, and you can think of them as the proven blueprints that great developers use to build code that's not just working, but actually flexible and elegant.
I mean, it's the universal story, right? You add a feature here, you fix a bug there, and before you know it, the whole code base feels brittle. Like you're scared to touch one thing because you have no idea what it's going to break somewhere else. So the real question is, how do we build software that can actually grow and change without just collapsing on itself?
And that, right there, is where design patterns come into play. Now, these aren't just snippets of code you can copy and paste. No, think bigger. They are high-level, reusable solutions for the problems that pop up over and over again in software design. They give us a shared language and a toolkit for these big architectural challenges, and they usually fall into three main families. Let's kick things off with the first one, how we make stuff.
All right, first up, we've got Creational Patterns. And just like the name says, this whole category is about one thing and one thing only, the process of creating objects. They give us really flexible, really controlled ways to bring our objects to life.
The keyword here, you got to remember, is abstraction. What creational patterns do is they separate your code from the specific concrete classes it needs to create. What does that mean for you? It means you can add all new kinds of objects into your system without having to go back and rewrite all the code that uses them. Let's check out a classic example to see exactly how this works. So picture the code for a mobile shop. On the left, you see the problem. Every time a new phone model comes out, you've got to hunt through the code, changing new statements in dozens of files. It's risky, it's messy. But on the right, the factory pattern gives us this beautiful, elegant solution. You just centralize all that creation logic into one single spot, a phone factory. Now the shop just has to ask the factory for a phone, and the factory takes care of all the details. And the workflow is just so clean. The shop's code is now completely separated from the specific phone classes. It doesn't care if it's an MiBolt or an MiFire. It just says, hey factory, I need this model, and the factory hands back the right object. Now, if you want to add a new phone, you only have to update one place. That's a huge win. This idea of decoupling also applies to how we put objects together, which brings us to our next category. Next up are the structural patterns. So if creational patterns are about making objects, you can think of structural patterns as being all about composing them. They're like the architectural glue that lets us assemble objects and classes into bigger, more flexible structures.
The big idea here is using composition instead of just inheritance all the time. These patterns help you combine simple objects to build really complex ones, all while making sure that the individual pieces stay independent and reusable. This is absolutely critical if you want to build systems that can evolve without needing a massive rewrite every 6 months.
Okay, check out this problem from an edtech platform. If they use normal classes for their membership bundles, adding new features creates what's called a class explosion. You get this insane, unmanageable number of combinations. But the decorator pattern on the right, it offers a brilliant way out. Instead of making endless subclasses, you just dynamically wrap a base object with these feature decorators at runtime.
And here's how easy that wrapping idea is in practice. You start with your basic subscription. The user wants to add Doubt Sessions? Boom, you just wrap the base object with a Doubt Sessions decorator. They need assignments too? No problem, you just wrap it again. See, each layer adds new functionality without ever having to go back and change the original class. It's just pure, flexible composition.
And that brings us to our third and final category, behavioral patterns. Now these patterns are all about communication. They focus on how objects talk to each other and how responsibilities get passed around, which ultimately makes the whole system a lot more flexible.
The big goal here is something called loose coupling. You can think of it like this. It's like having colleagues who can work together perfectly just by sending well-defined emails. They don't need to know every little detail about how the other person does their job. And this is so important for building systems where you can swap out components or change them independently without breaking everything. Oh man, here's a problem we've all seen before. A giant block of if-else statements handling payment logic. Adding a new payment method is a nightmare. It's messy, it's risky. But the strategy pattern, it cleans this up completely. It takes each algorithm, each different payment method, and wraps it up in its own little strategy class. The shopping cart then just gets to pick the strategy it needs when it's time to pay.
And the flow is just beautifully simple. The shopping cart has no idea how to process a Bitcoin payment versus a credit card payment. And you know what? It doesn't need to. It just holds a placeholder for some payment strategy. When the time comes, it just tells whichever strategy the user picked, hey, do your thing. This is loose coupling at its absolute best, and it makes the system so much easier to extend and to test.
So when you look at these three examples together, you start to see that these patterns aren't just some abstract academic theory. They really do form a practical, powerful toolkit that you can use to build better software. So let's just recap real quick. Creational patterns, like the factory, are there to fix rigid, high-risk ways of creating objects. Structural patterns, like the decorator, help you tackle inflexible structures and avoid things like that crazy class explosion. And finally, behavioral patterns, like the strategy, are perfect for untangling hard-coded logic and just improving how your objects talk to each other. The real trick is to first identify the kind of problem you have, because that's what's going to point you to the right category of solution.
And that's pretty much the whole shebang. These patterns give you a proven vocabulary and a set of strategies to turn that complex, rigid code into something simple and flexible. So the real question I have for you is, thinking about your own projects right now, what's the first piece of tangled code that comes to mind that you could simplify with one of these patterns? Thanks for tuning in.